Now, let's see how you can solve a right angle, right angle triangle, or a right triangle. So basically, you have to find the three sides and the three angles of the triangle. And let's see how you can find those given a limited amount of information. So basically, in order to solve a right angle triangle, you need to have two things. We have to find these two things. You have to find the two acute angles and the length of the three sides, right? As again, like I said, the three sides and the three angles. But again, in one of these angles is 90 degrees in a right angle triangle. That's why it's called a right angle triangle. So technically speaking, you already have one angle given to you, the 90 degrees, and you need to find the two other acute angles and the three sides. Okay. Now, we know the trigonometric ratio of an acute angle of the right angle of a right angle triangle involves three quantities, right? The lengths of two sides and the measure of an angle, right? So if you have the lengths of two sides and one angle, you can find the other quantities as well, right? So let's see an example. So you have this triangle over here. You already know this 90-degree angle. You know this 45-degree acute angle. So obviously, again, you can find the other angle over here, since the total of all three angles is 180 degrees. And then you're also given one of these sides. This side is 4, so you can find the other two sides by applying the trigonometric ratios, right? So since A is 45 degrees, this angle, again, in a triangle, we'll denote the three sides with A, B, and C. So the angle with A will denote as alpha, the angle with B will denote as beta, and the angle with C will denote with gamma, right? So that's just to make your life a bit easier. So alpha is 45 degrees. So beta is 90 degrees. In this case, we're giving beta 90 degrees. So this one is gamma, right? This one is beta. And obviously, the total of the angles inside a triangle is alpha plus beta plus gamma. And that equals 180 degrees, because that's the total of an angle inside a triangle. So you can find gamma by simply inserting the values. Alpha is 45, beta is 90. So obviously, the angle at B, gamma, will be 180 minus 45 plus 90, which is 45 degrees. So it's an equilateral triangle, right? So now you can find, basically, again, if you draw the triangle over here, let's say that this was the triangle, a rough sketch. This was 45 degrees. This is also 45 degrees. This is 90 degrees. And we know that this side is 4. So we need to find the other two sides. Sine 45. This is alpha. This is side A. This is side B. This is side C. So BC is 4. So sine 45, right? Sine 45, the sine of this angle, is the opposite over the hypotenuse, right? So BC over AB. Now, we know that BC is 4. We need to find AB. So now, oops, sorry. Let me just rub that off. So 4 over AB. Now we know from the table that sine 45 is 1 over under root 2, right? You can refer to the table back. And now you can find AB, which is equal to 4 into under root 2, right? Just cross multiply AB over here, under root 2 into 4. Now we know that now AB is 4 over under root 2. Now let's find this side, AC. So the cos of this 45-degree angle is the adjacent, which is AC, over the hypotenuse, which is AB. So you can just replace those values, and eventually that gives you AC is equal to 4, right? So now AC is 4. So now you have all of the requirements that you need. You have the three angles, 45, 45, and 90 degrees. You have the three sides, 4, 4, and 4 into under root 2. Also, you can make your life a little bit easier over here. Since this is an equilateral triangle, because this angle and this angle are both equal. That means since BC is 4, AC is also 4. And then you can just apply the Pythagorean theorem or anything, or the trigonometric ratio to find the hypotenuse.